For today's video, we're going to be solving a past paper question from 2017. It's a paper 2 question that focuses on the basics of differential calculus. So let's begin A. Find g prime of x. So it's asking us to find the derivative of g of x. It's actually really simple. You use the power rule for x to the power of 3 plus kx squared minus 15x plus 5. And for the derivative of this function, x to the power of 3, so 3 multiplied by x gives us 3x, and then 3 subtracted by 1 gives us 2. For kx, k multiplied by x squared gives us 2kx, and 15 minus 15x differentiated gives us minus 15. And now for part B1, show that k equals 6. So the question gives us the tangent to the graph of y equals g of x at x equals 2 is parallel to the line y equals 21x plus 7. So we already have the differentiated function, and if it's going to be parallel to the line, then the gradient must be equal to the gradient of this line. So therefore we equate it to 21. 3x squared plus 2kx minus 15 equals 21. And it also gives us y equals g of x at x equals 2. So we substitute 2 to find k. So 21 plus 15 gives us 36. Equals 36. And then 2 times multiplied by k multiplied by 2 gives us 4k. And then 2 to the power of 2 is 4, multiplied by 3 is 12. 36, and then 36 minus subtracted by 12 gives us 24. And 4k equals 24. Therefore k is 6. B2. Find the equation of the tangent to the graph of y equals the function gx at x equals 2. So we already have the gradient, which is 21 equals 21. We have the x point equals 2. And now we need the y coordinate to find the y-intercept of the equation of the tangent. To do this, we substitute x equals 2 back into g of x. So that will be 2 to the power of 3 plus k, which is equal to 6, multiply 2 to the power of 2, 15 multiplied by 2, and plus 5. And this will give us This will give us 7. So y equals 7. 7 equals gradient 21, 2 plus c to find the intercept, the y-intercept. 21 multiplied 2 is 42, plus c equals 7. So 7 subtracted by 42 gives us minus 35 equals c. So therefore, the equation of the tangent to the graph of y equals g of x at x equals 2 is y equals 21x minus 35. On to the speed part of the question. Use your answer to part A and the value of k. Find the x coordinates of the stationary points of the graph of y equals g of x. Since k equals 6, we put it back into g of x. 3 plus 6x squared minus 15x plus 5. And then we have to differentiate this to find the stationary points of the graph of y equals g of x. 3x plus 12x minus 15, and then it equals to 0. So this is a quadratic equation. By using the GDC, gives us x equals minus 5 or x equals 1. We plot these two x values on a sign diagram. So between minus 5 and 1, we choose a number in between those to determine whether it is a maximum point, a minimum point, or a stationary inflection point. So we plug 2 into the derivative of g of x. So that gives us a positive number. And then we're going to plug in 0. That gives us a negative number. And that gives us a positive number. So therefore, we can determine the minimum of the function is that x equals to 1, and the maximum is at x equals minus 5. Now onto D1. D1 is really simple. You plug -1 into the derivative or g prime of f of x. That will simply give us -24. For D2, hence justify that g is decreasing at x equals -1. Determine that g is decreasing at x equals -1, which we previously solved in D1. It gives us the number of -24, therefore it represents that g is decreasing at x equals -1. And last, for question E, find the y-coordinate of the local minimum. To do this, we already determined that the minimum is at x equals 1. So we plug in 1 back into g of x to find our y-coordinate. So 1 to the power of 3 plus 6 multiplied by 1 to the power of 2 minus 15 multiplied by 1 and then plus 5. So this gives us y equals -3.